Dear students, welcome to the one-shot series of industrial engineering. For GATE, primarily operations research is there in GATE syllabus. Before 2015, there were other topics including quality control, but post 2015, there was a major change in the syllabus of industrial engineering. So primarily, it's the operations research part. So in this one-shot series, we will be touching some of the important aspects of operations research and some industrial engineering. And my throat is gone because when I'm recording, my health was down. So that's the reason it is slightly different than the production. So, so today we are going to discuss graphical. It is a short topic. Then next lecture will be simplex. Simplex lecture will be big. But the foundation of simplex lecture is graphical. Okay, na? So this is our team Drona, and each and every member of the team is expert. So it is not run by one or two people, it's a team. And if I go, because in the previous lecture I have gone in the details of each and every member, but now I will not consume your time here because you will be seeing these lectures, previous lectures, so you will be knowing. So in the graphical method, what I am going to cover, once again, in one shot series, graphical lecture will be short. But there are very, very important fundamentals in that, okay? So I will be covering some basics of graphical. Then I will be covering the lines of objective function, how to draw the lines of objective function. Because in GATE, sometimes very tricky question comes. And one such question I have incorporated in the discussion. By the way, this one-shot series lectures are in English. For English, we have done the crash course, okay? Now, what is unbounded problem? How the graphs look like for unbounded problem, and how the graphs look like for no feasibility solution. So all these things we are going to discuss in this lecture. This is my details. I am Dr. 𝐂𝐨𝐻 Singh. I am gold medal in BTech from Aligarh Muslim University because I was university topper for class 93 to 97. Okay, 97 class. I am also MTech and PhD from IIT Delhi. Between MTech and PhD, 1.5 years I worked for engineering services. I was ex-IAS officer. And I'm a researcher. As per Scopus data 2020, it's a published, Scopus data is a researcher data published internationally. For year 2020, I am a top 5% researcher in the world. So now, let us discuss the graphical method. Once again, if the total concept of graphical method are understood, entire simplex will be very, very easy because graphical is the foundation. Because graphical method is meant for two-dimensional problem. Two-dimensional problem means if there are only two variables. If there are only two variables, we go for graphical. And if there are more than two variables, we go for simplex. Okay, na? So we will study these things with the help of some beautiful examples. This is the first example. This is the first example. This is my objective function. This is my objective function. Objective function may be that of profit or cost. Objective function can be for profit or for cost. Now, if the objective function is for the profit, we will go for maximization, profit maximization. We will go for profit maximization. And if the objective function is that of a cost, if the profit function is that of a cost, or you can say loss, we will go for minimization. We will go for minimization. So in graphical method, objective function can be of maxima or minima. But the simplex and transportation cases will be different. We will discuss in the upcoming lectures. This industrial engineering is very, very easy. Just you have to have concept clear. So in graphical method, objective function can be a maxima function or a minima function. So it's a two-dimensional equation. There are only two variables. Now, in all the linear programming problems, you must have seen that these things are also given. X and y greater than equal to 0. Now, this is a very important constraint. This is very important constraint. You have to be very, very careful. You know, what does this indicate? What does this indicate? Suppose this is the x-axis and this is the y-axis. If it is given x and y greater than or equal to 0, it means your solution lies in the first quadrant. X is greater than equal to 0, y is greater than equal to 0. It means your solution lies in the first quadrant. We will not go for second, third and first quadrant solution. But suppose x is greater than equal to 0 and for y it is not given to you. For y it is not given to you means y is unbounded. If that is the condition, your solution lies in this quadrant. Solution lies in this quadrant. But let us say either first quadrant and second quadrant. Your solution lies in the first quadrant and the second quadrant. Okay, na? If x is unbounded, y is also unbounded. Your solution lies in all the four quadrants. Your solution lies in all the four quadrants. Because suppose x is less than equal to 0, y is less than equal to 0. Suppose this is the situation, your solution lies in the third quadrant. Your solution, suppose this is the constraint, it means your solution lies in the third quadrant. Okay? Suppose x is less than equal to 0, suppose x is greater than equal to 0, y is less than equal to 0, it means your solution lies in the fourth quadrant. But when these constraints are not given to you, means x is also unbounded and y is also unbounded, it means your solution can lie in any one of the four quadrants. your solution can lie in any of the 4 quadrant. So it's a very, very important information. That is the reason I told you to see this very, very carefully. To see this very, very carefully. Okay. So now, because my solution lies in the first quadrant, let us draw these lines. This is your first facility of first quadrant, first constraint, second constraint, and the third constraint. So what we do, let us see the first quadrant constraint divided by 90. Can I write x divided by 45 plus y divided by 90 is less than equal to 1? So see very, very carefully what I am going to do. See very, very carefully what I am going to do. Like x by a plus y by b is equals to 1. Suppose that is the equation I am going to plot on the graph. So x is 45 intercept, x-axis, y-axis. So intercept on the x-axis is 45. Y-axis intercept is 90. And my line is this. This is my first constraint. Now, you know what is the meaning of less than equality sign? What is the meaning of less than equality sign? Meaning is my region will be towards origin. Less than equality sign means my region is towards origin. Once again, this graphical you have to see very, very carefully. All the fundamentals should be clear. Then the simplex will be very, very easy for us. And remember, gate question comes. Suppose if it is a greater than equality sign, it's a greater than equality sign, my region will be away from the origin. Greater than equality sign, my region will be away from the origin. Less than equality sign, my region is towards origin. So that is your first constraint. Now see the second constraint, divide by 80. So x divided by 80 plus y divided by 40 is less than equal to 1. Okay, na? So now x-axis intercept is 80. Y-axis intercept is 40. And this is my equation for the second constraint. Second constraint. Okay, exactly the same procedure. Now, because it is less than equality sign, so my region will be towards origin. My region will be towards origin. Okay? It's very, very easy. Take the third constraint, divide by 50. X by 50 plus y by 50. No, it is also less than sign. There was some error because yesterday I was doing something. Less than equal to 50. Okay, na? Less than equal to 1. Now let us plot this. 50, 50, and my line is here. This is the third constraint. So because there is a less than equality sign, there is a less than equality sign, so region will be towards origin. Now see, what is the overlapping region? What is the overlapping region? Overlapping region will be this. This is the overlapping region of all the constraints. This overlapping region is called feasible region. It's called overlapping region is called feasible region. What is the meaning of feasible region? Your solution will lie in this area. Feasible region means your solution will lie in this area. Okay? Your feasible region means your solution will lie in this area. So what are the corner points of this feasible region? O, A, B, C, and D. These are the corner points of the feasible region. Now, there are two different ways to handle this problem. There are two different ways to handle this problem. Once again, although graphical method is a short lecture, but I want you to pay a very careful attention. If possible, you see this lecture again, because fundamentals should be clear. Now to handle this problem, there are two methods. Method 1. Method 1. You identify these corner points like O, A, B, C, D. You identify these corner points. For example, O, it's a 0, 0. A is y-axis, na? Can I say it's a 0, 40? Correct, na? D, 45, 0. 45, 0. Now this B will be the intersection point of constraint 2 and 3. B will be the intersection point of 2 and 3. So forget about these inequalities, take it as equal. Solve these two equations. Because it is a one-shot recorded series, otherwise in the live lectures we give time to the students to solve. So in the one-shot series also you should have calculator rough copy with you, okay na? So now find out the intersection point of 2 and 3. 2 and 3, and find out the coordinate B. I am having the solution. It is 20, 30. Generally in the one-shot series, what I am doing, I am giving some small 30-second and 20-second break so that you can solve it. Okay. So intersection point between 2 and 3 is B. Now C is the intersection point of 1 and 3. Correct? Intersection point of 1 and 3 is point C. Intersection point of 1 and 3 is point C. And if you solve it, it is a 41. Okay, it is a 40, and because I have solved this, okay. But in one shot series, if you are a little fast, you can solve along with me, because this calculation is not that difficult. Okay. Otherwise, in one shot series, there is another possibility. You pause the video and then solve it. You pause the video and then solve it. Or I am also giving 20 seconds and 30-second fillers. Now, what you do then? Do one thing. You know all the corner points. Find out the value of objective function. Find out the value of objective function at these corner points. So put 0, 0. So this will be 0. Put the value of a in the objective function 0, 40. So 40. So it will be 1600. Okay. Put the value of 20, 30. X is equals to 20. Y is equals to 30. And find out the value of objective function. It will come out to be 2100. Put the value of C, 40, 10. X is equals to 40, Y is equals to 10. And this is 2200. 2200. Next is 450, and the value is 2025. Okay. So find out the corner points of the feasible region, and on those points find out the value of objective function. Now see here, objective function is the maxima function. Objective function is a maxima function. So now, what is the maximum value of objective function? 2200. Maximum value of objective function is 2200. So now, this is your IO. This is the optimum value. I mean, C is the optimum point. C is the optimum point. An optimum value of objective function is 2200. Optimum value of objective function is 2200. So this is the first way. This is the first way to find out the solution of graphical problem. First way to find out the solution of graphical problem. Now, please remember, in GATE there is a time crisis. In GATE there is time crisis. So we may not have time. we may not have time to calculate each and every point and then find out the objective function value. We may not have time. So there is one more method. There is one more method. This is your feasible region. O, A, B, C, feasible region. One, two, three. These are 1, 2, 3. First constant, second constant, and the third constant. Okay, na? Do one thing. Calculate the slope of each constant. Calculate the slope of each constant. So first constant is the 2x plus y is equals to 90, because I don't want to do it here, because these notes will go to you, it will be hodgepodge. So can I write here y is equals to minus 2x plus 90. So m1 is equals to minus 2. See, can I do that? First constant, slope is minus 2. Correct, na? Simple mathematics. Constant 2, y is equals to mx plus c. Y is equals to mx plus c. So here the slope will be m is equals to minus 1 by 2. Second constant, m2 is equals to minus 1 by 2. So m1 is minus 2, m2 is minus 1 by 2, and m3 is minus 1. m3 is minus 1. So these are the slopes. So slopes in ascending order, minus 1 by 2, minus 1, minus 2. This is the order of quantity. Forget about the sign. Ascending order of quantity. Correct? Understanding that? Slope. Calculate the slope. Arrange in the ascending order of quantity. Now find out the slope of objective function. Find out the slope of objective function. Objective function is this. So can I say slope here is minus 45 by 40, y is equals to mx plus c na? So m is equals to 45 by 40. Objective function slope is minus 45 by 40. Calculate the slope of objective function. Now you see where the slope is lying. Objective function slope is lying between these two, because it is quantity more than 1 but less than 2. So objective function slope is lying between -1 and -2. -1 is the slope of constant 3 and -2 is the slope of constant 1. -2 is the slope of constant 1 and -1 is the slope of constant 3. So the optimum point will be the intersection of constant 1 and 3. That is point C. Optimum value will be the intersection of point constant 1 and 3. See, that's what our solution was now. Previously we solved like this only. This is called slope method. This is called slope method. This is called slope method. Now, what is the science behind this? What is the science behind this? Whatever we have done, what is the science behind it? First method was you calculate each and every corner point and calculate the objective function value at each and every corner point and try to find out. We have done this problem. And the second method is as the slope method. Please hear this very, very carefully. I'm again reminding you. Please hear this very, very carefully. What is the science behind this? The objective function line is y is equals to -45 by 40 into x. This is my objective function. This is my objective function line. Now here very carefully, it's a very, very important point. Whatever I'm going to speak to you, it is a very, very important point. Draw this line passing through the origin. Draw this line passing through the origin. Now, now extend the objective function line towards the feasible region. Extend the objective function line towards the feasible region. I hope you are hearing very, very carefully. When we are shifting the objective function line towards the feasible region, the first point of contact, the first point in the feasible region, objective function line touches is the point of minima. So you keep on shifting it. All these solutions are optimum solution. All these solutions are optimum solution. All these solutions are feasible solutions, but not optimum, because the lines coming in the feasible region are the feasible solutions, but not optimum. Once again, it's a little technical point. You are drawing the objective function line passing through the origin. Now shift this line towards the feasible region. So the first point of contact between the feasible region and the objective function line is a point of minima. And then keep on extending. All these solutions are feasible solutions, but not optimum. Now the farthest point The farthest point at which objective function lines is touching the visible region is called optimum. The farthest point at which the objective function line is touching the visible region is called optimum solution. So C is the optimum point. So that is the science behind this. And whatever I have discussed with you till now, it is the basics of graphical. It is the basics of graphical. Okay. And this first 35 minutes lecture of graphical was very, very important. Okay. Once again, in the one shot, we are discussing only the important things. Question number 2. Question number 2. We are learning graphical with the help of questions. A certain company produces tea trays and ashtrays out of sheet metal. Following data is given on capacity, availability, and economics of each product. Determine the optimum production schedule. It means how many ashtrays and how many tea trays we have to produce. How many ashtrays and how many tea trays we have to produce. Stamping, the available time is 30,000 seconds. Forming press, ashtray consumes 15 seconds, tea tray consumes 5 seconds, and the total available time is 30,000 seconds. Okay, na? Because we cannot exceed this time limit on each machine. We cannot exceed this time on each machine. Let us say we are producing X number of ashtrays and Y number of tea trays. We are producing X number of ashtrays and Y number of tea trays. Now the ashtray contributes rupees 20 to the gross profit. It contributes 20 rupees. And the tea tray contributes 30 rupees. And the fixed cost is 45,000. Fixed cost is 45,000. So what will be my objective function? Because it's for profit, objective function is maximum Z is nothing but 20x plus 30y minus you you subtract the fixed cost, because my objective function is that of net profit. Selling price minus fixed cost will give me the profit. So constants are 10x plus 20y is less than equal to 30,000. 15x plus 5y is less than equal to 30,000. It's a gate problem. It's a PYQ gate problem. Okay, na? So it is that is the first constant. And xy should be greater than or equal to 0. because I cannot say that I will produce minus 2s trace or minus 5t trace. I cannot do that. It should be a real positive number. So my solution will lie in the first quadrant. My solution will lie in the first quadrant. And the objective function is maximum z is equals to, see constants are here, 10x plus 20y less than equal to 30,000, 15x plus 5y is less than equal to 30,000. Profit, net profit objective function is 20x plus 30y minus 45,000 minus 45,000. So this is my problem, okay? Because the problem is two-dimensional, so solve by graphical method. Same. Plot this one. So x divided by 3000. Correct, na? Y divided by 1500. Constraint 1. Same thing I am doing, but whatever we learned before. This is x divided by 2000 plus y divided by 6000 less than equal to 1. So x is 2000, this is 6000. So this is your feasible region. This is the feasible region. Okay. Okay. O, A, B, C. All right. So now let us go by slope method. Slope is minus 1 by 2. Slope is minus 3. And objective function slope is minus 2 by 3. See here, very, very important. See what I am going to discuss now, very, very important. X-axis has got slope 0. Y-axis has got slope infinity. Because these are also constraints, na? X is greater than equal to 0, y is greater than equal to, these are also constraints. So x-axis will have a slope of 0 or y-axis will have a slope of infinity. I will give you some example. Let us say these are the slopes of two different constraints. Let us say objective function slope is a minus 1 by 4. Then what to do? Let us say objective function slope is minus 1 by 4. You should remember that x-axis is having slope 0 and the y-axis is having slope infinity. So minus 1 by 4 is appearing here. So you know what is my conclusion? My conclusion is my optimum point will be intersection of x-axis and first constraint. The optimum point will be the intersection of x-axis and the first constraint. Let us say objective function slope is minus 4. Let us say objective function slope is minus 4. It means it is appearing here. You know, what does this indicate? Optimum point will be intersection of second constraint and y-axis. Second constraint and y-axis. I hope all of you are okay. So these industrial lectures will be fantastic when you are live, because in the crash course also you are live, and Abhyas you are live, and in our regular courses you are live. So when you ask question, I answer. You know, some basic fundamentals you have doubt, I answer. So there's a totally different mechanism. But you know, we want to help. PW wants to help all the students, especially from South India and Northeastern state, where they do not understand Hinglish. So these are recorded lectures we are putting over the YouTube on the English channel. So that is the idea. It's a free. But you know, I'm industrial, I'm giving you everything, and I'm 100% sure that if you focus on these lectures, 99% problems in the gate you will be able to hit. 99% of the problem in the gate you will be able to hit. Now you have to be little careful. You have to be little careful with the slope method. You have to be little careful with the slope method. Looks easy, na? Before giving the answer, please check. Once again, everybody should hear very, very carefully what I am saying now. If the point is coming in, if the point is calculated by slope method, before giving the answer, please check that whether this point is falling in the feasible region or no. Before hitting the answer, you please check that whether this point, whatever you have calculated from the slope method, is falling within the feasible region or no. Correct, na? I have seen one problem in GATE. It was a very good problem. By the slope method, whatever you have calculated, it was not falling in the feasible region. So keep on extending the objective function line. You have to see the farthest point. Okay, na? So this problem, coming to this problem, my objective function slope is lying in between. So intersection of these 2 points, I mean this one, will be the optimum point. Calculate the intersection point of these two. Calculate the intersection point of these two. 1800 and 600. 1800 and 600 is the point B. Put this value in the objective function. So maximum net profit, put the X value 1800, Y value 600. The maximum Z will be 9,000 rupees. 9,000 rupees net profit is your optimum value. Is your optimum value. Correct, na? So it was a very good problem. It was a very good problem. Now this one. Problem is maximize Z subjected to these three constraints. Subjected to these three constraints: constant number 1, constant 2, constant 3. The problem is you have to draw the objective function line of 3, 6, 9, 12. You have to draw the objective function line of 3, 6, 9, 12 over the feasible region. 3, 6, 9, 12 over the feasible region. It's also a very, very important problem, and we will learn many, many fundamentals with the help of this problem. We will learn many, many fundamentals with the help of this problem. So can you graph? Because in between I want to give you some small 30-second break so that you can you draw it? Can you draw it please quickly? I will draw after 30 seconds. Please draw it. Actually today health is totally down, but we have to record and send to our team. It has to go on time because we follow very strict schedule. Although I'm not feeling well, fever, but still discipline is discipline. Okay, now draw. Because 23 years, unless if I'm not able to get up from the bed, only in that case I have, otherwise I have always stick to the schedule. I started my journey in year 2000. Because some people say, sir, you are not Indian, because Indians are always late and they never stick to the schedule. But you are always punctual. So anyway, I am having fever today when I'm recording it. Okay. Okay, let us draw it. First constraint, x by 6 plus y by 6. So 6. Constraint 1. It is a very, very important problem. Very important fundamentals we are going to learn from this. Because it is less than a sign, it means region will be towards the origin. Region will be towards the origin. X is less than or equal to 3. So 3. Again, 3 means x then less than or equal to 3. So less than means region will be towards the origin. This is my second constraint. Now third constraint is x1 divided by 2 x2 divided by 4 third constraint. Okay, and because it is greater than sign, so region will be away from the origin. Because it's a greater than sign, region will be away from the origin. So my feasible region is this. This is my feasible region. This is my feasible region. Less than equality sign means region will be towards the origin. And greater than sign means region will be away from the origin. Okay, so now here very carefully what I am saying, it is a very important point. It's a very important point. Slope method, you know why I have taken new slide? Because these notes will be available to you, because our memory is short. So although I am speaking and you are hearing, but you will forget. In Telugu we call it much poendi. So if the writing notes are there with you, it will stick to your mind. If you are applying the slope method, and if the objective function is maxima, we see the slope of only less than equality sign. We see the slope of constraints of only less than equality sign. Okay, now if my objective function is that of minima, if the objective function of minima, I see the slope of constraints of greater than equality sign. These are the basics. Simplex, I will take you to a very deep level. Generally, most of the teachers in the coaching setup, they don't touch those things. But it is not justice to the students. And I think because there's a 2 days time, my health will also improve. So I will be more enthusiastic while recording simplex method. So if the objective function is maxima, I will not see these constraints. I will see only these constraints. If the objective function is of a minima, I will not see these constraints, I will see these constraints. Correct, na? I hope all of you are catching it. But if it was live, it would have been a different mechanism. Okay. Maxima means I will see only these three, I will not see this. Okay, na? So M1 is nothing but -1. Correct, na? And M2 is infinite because this line will have infinite slope. And objective function slope is -2. So -2 appears between these two. So this is my optimum point. Optimum point will be x is equals to 3 and put 3 here, so x2 will also be 3. 3 and 3 are optimum point. Correct, na? Either is okay. Put this in objective function. Maximum z is 2 into 3 plus 3 comes out to be 9. So maximum value of objective function is 9. Maximum value of objective function is 9. Maximum value of objective function is 9. Now the question is asking a very interesting thing. Draw the lines of these. So 9 is the optimum one. So objective function is x2 is equals to -2x. So it is like this. So z is equals to 0. So how to plot value 3? How to plot the value 3? Two x1 plus x2 is equals to 3. So x1 is equals to 1.5. x2 is equals to 3. Z is equals to 3. Remember, z is equals to 3. Remember, z is equals to 3 is not falling in the feasible region. It is not falling in the feasible region. So this solution doesn't exist. Z is equals to 3 solution doesn't exist. Now 6, 2x1 plus x2. So x1 will be 3, x2 is equals to 6. Z is equals to 6. Z is equals to 6 is a feasible solution. Z is equals to 6 is a feasible solution. See how it is a feasible solution? Because it is lying in the feasible region. Why it is a feasible solution? Because it is lying in the feasible region. But it is not optimum one. It is a feasible solution, but it is not an optimum one. correct? 9 is optimum because 9 we have calculated, it's an optimum one. Uh, 9 is the optimum feasible solution. 9 is the optimum feasible solution. And corresponding to 12, line will appear here beyond the feasible region. 9 will appear here beyond the feasible region. So this is also not a feasible solution. Z is equals to 12 is also not a feasible solution. Z is equals to 3 is also not a feasible solution because objective function line is not appearing in the feasible region. So it is not a feasible solution. Z is equals to 6 is going through the feasible region. So it's a feasible solution. It's a feasible solution. And Z is equals to 9 is an optimum feasible solution. Z is equals to 9 is an optimum feasible solution. Okay, is that all right with everyone? See, there is a very, very important thing I want to introduce now. There is a very, very important thing I want to introduce now. Your optimum point is 4010. Your optimum point is 4010. This is the problem number 1 that we have did. It's a little important point. Please focus on the board. 4010 is the optimum point. These 3 constraints are facilities. These 3 constraints are facilities. Now, at the optimum condition, see very, very carefully. At the optimum condition, you would like to know the percentage utilization of facility 2. This facility 2, how much percentage utilization is there? Optimum point is 4010. So, percentage utilization of facility number 2, 4010 is the optimum point. Facility 2 is 2x plus x plus 2y is equals to 80. So percentage utilization is, put the value of 4010 here. So 40 plus 2 into 10. This is the facility we are using. Available capacity is 80. 20 plus 40, 60 divided by 80 into 100. That is the way we calculate percentage utilization of any facility. That is the way we calculate percentage utilization of any facility. So in GATE exam, when the percentage utilization is being asked for any facility, after calculating the optimum point, that is a way to handle. That is a way to handle. Okay, percentage utilization, how to calculate? Put the value in this is the next problem. This is the next problem. Can you graph it? Please graph the problem. Please graph the problem. 30 seconds I will wait, because one shot series also you should sit with the pen and paper. Otherwise, there is no benefit unless and until you write. Some of you may be preparing for civil services also, because many of my students, they did so in the previous 23 years. Many of my students are IAS officers. Even history and geography, whatever you read, please write. Whatever you read, you please write. So, first constraint, x divided by 20 plus y divided by 100 is greater than 1. So, plot it. 20, 100, this is constraint 1. Constraint 2, x divided by 40 plus y divided by 60 greater than or equal to 1. So, x is 40, y is 60. This is constraint 2. This is constraint 2. Because it's a greater than sign, region will be away from the origin, correct? Na? Region will be away from the origin in both the cases, because the sign is a greater than or equal to sign. For each constraint, I am using a different color, okay, so that it is good for you. X divided by 90 plus y divided by 30 is greater than or equal to 1. So, x-axis is 90 intercept, y-axis is 30. This is the third constraint. So, all the regions will be away from the origin, and the common region is this. This is the feasible region. And the feasible region extend to infinity. Feasible region extend to infinity. Feasible region extend to infinity. My objective function is a minima function. Slope here is -5. Slope here is -3/2. Slope here is -1/3. Objective function slope is -2/3. Correct, na? I hope everybody is okay with this. So, -2/3 appears here. So, -2/3 appears here. So my optimum point will be the intersection of constant 2 and 3. Means this is the optimum point. Optimum point will be the intersection of these two. That is the optimum point. Okay. Because our objective function is a minimum function, so the way we do it, draw the objective function line passing through the origin and extend this line towards the feasible region. Extend this line towards the feasible region. The first point, because it's a minimum function, the first point objective function touching the feasible region is the optimum point. So intersection of 2 and 3 is 180 by 7. Uh, 180 by 7 and 150 by 7. (180 by 7 and 150 by 7 is the optimum point. And this value, if you put in the objective function, it will be 810 by 7. It will be 810 by 7. 810 by 7. Because it's an objective function is a minimum function, so we will extend the line towards the feasible region. The first point, objective function is touching the feasible region, is an optimum point. Everybody's okay? Everybody's okay? This is also a very beautiful problem. See, the best would have been if all of you are live. Then I could have, churned the nectar. But anyway, if anybody is having doubt, you please join the Telegram channel. Dr. 𝐂𝐨𝐿𝐴, I think, will be reflecting there, and direct all the doubts to queries to me. I will be taking care of your queries. Okay. So this is slightly different problem. First constraint, x1 divided by 15 plus x2 divided by 10 less than equal to 1. So 15, 10, constraint 1. Now we are expert now. Once again, in one shot series, you should also have pen and paper with you. Practice together. First constraint, second constant x1 divided by 8 plus x2 divided by 12 is less than equal to 1. 8, 12. Constant number 2. So here both the constants are having less than sign. So region will be towards origin. So first two constants, because it's a less than equal to sign, region is towards origin, and third constant, because it is a greater than sign, region is away from the origin, and the overlapping region is called feasible region. Overlapping region is called feasible region. This is the next problem, because there was some, I think, camera glitch. It's a unique problem. I will tell you how this problem is unique. I will tell you how this problem is a unique problem. How this problem is a unique problem. I will tell you that, okay? How this problem is a unique problem, I will tell you that. So because the objective function is a maxima function, because the objective function is a maxima function, I will see the slope of only these two. I will not consider this one. I have discussed that before. See the slope of this thing. I will not discuss this thing. Okay. So the slope here is minus 3 by 2. Slope of this is minus 2 by 3. And the slope of this is minus 3 by 2. Slope of the second constant is minus 3 by 2. So now objective function line, you plot in such a way that it passes through the origin, like this. Objective function line, you draw in such a way that it passes through the origin. Now this objective function line you shift towards the feasible region. Objective function line you shift towards the feasible region, and because it's a maxima function, so the farthest point at which objective function line makes the contact with the feasible region is your optimum point, optimum point. Now, what is the situation here? What is the situation here? Slope of objective function line is equal to the slope of the one of the constraint. Slope of objective function line is equal to the slope of one of the constraint, is equal to one of the slope of constraint. So when you are shifting at the farthest point, what will happen? Objective function line will superimpose over objective function line will superimpose over the constant line. See the blinking line? Objective function line will superimpose over the constant line. So that's what will happen. Because line is objective function line is superimposing over the constant line. So between this point, let us say this point is A and this point is B, all the points appearing on this line will be optimum points. And each and every point will give you the optimum solution. Because if the slope matches, then on the entire line falling on the feasible region, entire line falling on the feasible region will give you the optimum point. So the line segment between A and B, how many points are there on the line AB? Infinite points. Line AB, there are infinite points. So all those points will give you a solution. So you know what will be your answer? There will be alternate solutions. There will be alternate solutions. Alternate solutions, or you can say infinite solutions. Alternate solutions means infinite solutions. Corresponding to this, what exactly happens in the simplex, I will tell you in the next lecture. That this particular graphical method, how exactly it reflects on the simplex, I will tell you that. So you have to identify the points, point A and point B. Point B is easy, it's a 8, 0. Point A is intersection of the first and the second constraints. It's a intersection of the first and the second constraint. 12 by 5 12 by 5 and 42 by 5. 12 by 5 and 42 by 5 is point A, and the point B is 8, 0. So if you find out the value of objective function, if you find the value of objective function corresponding to A and B, it will be same. Objective function is here. So corresponding to B, it's a 48. 8, 0, put it here. 8, 6 are 48. Now A, if you put the value of A here also, x is equals to 12 by 5 and y is equals to 42 by 5, you will get exactly 48. Because that is the meaning of alternate solution. There are alternate optimum solution. When we will get alternate optimum solution? When the slope of objective function line is matching with the constant line. Slope of objective function line is matching with the constant line. We will get alternate solutions. Now, some of you may ask that you are saying that between line segment between A and B, there will be infinite points. So where are those infinite points? Where are those infinite points? So how exactly to calculate infinite points? So point A, point B. Point B is 8, 0, and point A is 12 by 5 and 42 by 5. 12 by 5, 42 by 5. And all the points on the line segment AB will give me the optimum point. So how to find out all the optimum points? How to find out all the optimum points? How we do it? Lambda matrix of A, 12 by 5, 42 by 5, it's a point, plus 1 minus lambda into point B, and the point B is 8, 0. You can say x1, x2. Lambda value varies between 0 to 1. Lambda value varies between 0 to 1, means at point 1, point 11, point 112, point 2, point 3. So how many values are possible between 0 and 1? Infinite. How many values varies between 0 and 5? It is infinite. So any value of lambda between 0 to 1 will give you an optimum solution. So if the slope of constant and objective functions are matching, it leads to infinite solutions. It leads to infinite solutions. It leads to infinite solution. So it was a very, very important concept, and I hope you have grasped it in this one-shot series. Kindly remember that same thing I will tell you how exactly we see this alternate solution or infinite solution on a simplex table. How exactly we see on a simplex table, I will tell you. Okay, na? It was a very, very important problem. What I recommend to all of you, that you please see this graphical method 2 times. One time with the pen and paper, and another time just watch. Because fundamentals of graphical methods are very, very important to understand the simplex. And when I'm recording simplex, my health will be better, so I will take you to deep insight. Okay, na? And if there is any question, please ask me in Telegram. This is the next problem. Can you graph it, please? Next problem, can you graph it, please? Graphical lecture is a very short, less than 2 hours, but simplex will be approximately 5 hours, because there are different permutation and combinations in simplex. Okay, so let us plot. Let us plot constant 1, x1 divided by 1 plus x2 divided by minus 1 less than equal to 1. Correct, na? Because 1 will come down. So 1, x1, x2 minus 1. Because it's less than 1, region will be towards origin. This is the first constant. Region will be towards origin. Region will be towards origin. Second constant, x1 divided by 3 plus x2 divided by 3 greater than or equal to 1. So 3. Because it is a greater than or equal to sign, region will be away from the origin. Region will be away from the origin. So this is your feasible region. This is your feasible region. Feasible region. Now, my objective function is a maxima function. My objective function is a maxima function. So what is the maxima function? Optimum solution. Draw a line passing through the origin. Shift it towards the feasible region. Shift it towards the feasible region. The farthest point means the last point, farthest point at which objective function line touching the feasible region is the point, optimum point. Na? That's what the optimum point we have discussed in this lecture. But the issue is, my feasible region is extending to infinity. My feasible region is extending to infinity. Feasible region is extending to infinity. So objective function line will touch the farthest point at infinite. Okay, na? At infinite. Such problems are called unbounded problems. So what is the answer? This problem is unbounded. This problem is unbounded. Correct, na? Easy, na? Huh? It's easy if it is learned properly. It is very easy. Hinglish also, we have excellent teachers and team Drona at PW. We have excellent teachers for each and every. In the Hinglish, those who taught English is my responsibility, industrial. For Hinglish also, they have did an excellent job. Last problem for the graphical. Plot it, giving you 30-second break time so that you can plot it. Plot it, please. X1, X2. My first constraint, x1 by 1 plus x2 by 1 is less than equal to 1. So 1, 1. This is the region because it is less than 1, na? So this is the region. Correct. Constraint 2, x1 is minus 1 plus x2 divided by 3 is greater than equal to 1. So x1 is minus 1, x2 is 3. Now, greater than equal to sign means a region will be away from the origin. A region will be away from the origin. This indicates my solution should lie in the first quadrant. This indicates that my solution lies in the first quadrant. So region away from the origin means, see this one. Correct, na? So in this problem, there is no overlapping region. No overlapping region. No overlapping region means no feasible region. No feasible region means no solution. this problem will not have any solution because there is no overlapping feasible region. This problem will have no solution because there is no feasible overlapping region. Correct, na? In the simplex also I will tell you what is the corresponding matrix with respect to no feasibility. So that's what was your graphical. So graphical was easy and short topic. In the next lecture is going to be a big lecture. I am slowly dismantle everything. Thank you very much. Keep in touch.